Welcome to the session on Introduction to Information Security. Our view of security. Let me start with a very common question. What do you mean by security? We all have our own view on security, but it is very difficult to formally define the concept of security. We feel secure inside our houses or our premises with non-people. If we closely watch mankind, there is a quest to be secure, to guard our valuables, to restrict the entry of strangers and build barriers surrounding our asset. So, we always try to build a secure and safe environment to live and work. A simple definition of security is protection from attacks or harm. It's a process of keeping away from things that may cause malicious injury or dangers. Until recent, we need to consider only the physical security, but now information system is more on threat. Physical security deals with safeguarding our assets or people from intruders or malicious attacks. So, how do we protect our most valuable asset? Yes, the simplest answer is keeping them in a safe place. Nowadays, asset protection is easier with many factors working against potential criminals. Sophisticated alarms and camera systems silently protect secure places like banks without considering the people around. But today, more attacks are happening on information systems. Some important aspects for the need of security in today's corporate environment are increasing threat of attacks, availability of tools and internet resources to attack systems, rapid growth of computer networks for information sharing, sharing of confidential information through enterprise systems networks. Products in the market concentrate more on ease of use than security in computing. Lack of specialized resources that may be allotted for securing systems. Hence, we will discuss different types of information which are vulnerable for attacks and the security trends in the coming parts. Information security concepts. The number of internet users has crossed 6 billion by January 2022, which is the 75% of the world population. The internet is a worldwide network of networks that can be accessed using computers, mobile phones, PDA, digital TV, etc. Along the easy access to the information, there is some risk associated with that, including loss of valuable information, information getting stolen, altered or misused. The information available on the internet is more vulnerable than the information printed and locked. Intruders can steal the information even without entering the office or home, even the country. Thus, information security is more critical for the present age. Any part of a computing system can be marked of a crime. A computing system means a collection of hardware, software, storage, data and people performing computational tasks. At times, we think that these parts are not valuable to an outsider. For example, in a bank, we assume that the most valuable property in a bank is the cash or gold. But in fact, the customer information in the bank's computer is more valuable. This information can be used in countless ways to make money criminally. A competing bank can use the information to disrupt services and discredit the bank. A crooked individual can use this information to move money from one account to another without the consent from the owner. Large depositors may be contacted and convinced to invest in fraudulent schemes. Thus, variety of attacks possible makes the computer security very difficult. In real life, any robber would try to penetrate the weakest point for easier access. Similarly, unguarded access by means of a simple telephone line may be used by intruders. This idea is termed as principle of easiest penetration. Principle of easiest penetration. An intruder must be expected to use any available means of penetration. The penetration may not necessarily be by the most obvious means, nor is it necessarily the one against which the most solid defense has been installed. And it is certainly does not have to be the way we want the attacker to behave. Thus, a computer security specialist must consider all possible means of penetration. Strengthening one aspect may simply make another more tempting to intruders. Thus, the different ways by which a system can be attacked should be dealt with at most care. Types of information security. Information security is a set of tools and practices that you can use to protect your digital and analog information. There are different subtypes for information security. These subtypes include specific types of information and use certain tools to protect information and domains where information needs protection. Some of them are listed below. Application security. Application security strategies protect applications and application programming interfaces (APIs). These strategies can be used to prevent, detect and correct bugs or other vulnerabilities in your applications. If not secured, application and API vulnerabilities can provide a gateway to a larger systems, putting your information at risk. These strategies may be used with the application you are using as well as the application you are developing. Infrastructure security. Infrastructure security strategies protect infrastructure components including networks, servers, client devices, mobile devices and data centers. The growing connectivity between these and other infrastructure components puts information at risk without proper precautions. An important goal of infrastructure security is to minimize dependencies and isolate components while still allowing in their communications. Cloud security. Cloud security provides similar protections to application and infrastructure security, but is focused on cloud or cloud connected components and information. Cloud security adds extra protections and tools to focus on the vulnerabilities that come from internet facing services and shared environments such as public clouds. Another aspect of cloud security is collaboration with your cloud provider or third-party services. When using cloud-hosted resources and applications, you are often unable to fully control your environments since the infrastructure is typically managed for you. This means that cloud security practices must account for restricted control and put measures in place to limit accessibility and vulnerabilities stemming from contractors or vendors. Cryptography. Cryptography uses a practice called encryption to secure information by concealing the contents. When information is encrypted, it is only accessible to users who have the correct encryption key. If users do not have this key, the information is unintelligible. Security teams can use encryption to protect information confidentiality and integrity throughout its life, including in storage and during transfer. There are different algorithms and techniques used to do encryption, which we will see later. Incident response. Incident response is a set of procedures and tools that you can use to identify, investigate and respond to threats or damaging events. It eliminates or reduces damage caused to systems due to attacks, natural disasters, system failures or human error. This damage includes any harm caused to information such as loss or theft. A commonly used tool for incident response is an incident response plan (IRP). IRPs outline the roles and responsibilities for responding to incidents. These plans also inform security policy, provide guidelines or procedures for action and ensure that insight gained from incidents is used to improve protective measures. Vulnerability management. Vulnerability management is a practice meant to reduce inherent risk in an application or system. The idea behind this practice is to discover and patch vulnerabilities before issues are exposed. The fewer vulnerabilities a component or system has, the more secure your information and resources are. Disaster recovery. Disaster recovery strategies protect your organization from loss or damage due to unforeseen events. For example, ransomware, natural disasters, or single point of failure. Disaster recovery strategies typically account for how you can recover information, how you can restore systems, and how you can resume operations. These strategies are often part of a business continuity management (BCM) plan designed to enable organizations to maintain operations with minimal downtime. Security trends. In 1994, the Internet Architecture Board (IAB) issued a report entitled Security in the Internet Architecture. The report stated general consensus that the Internet needs more and better security and identifies some key areas for security mechanisms. Secure the network from unauthorized monitoring, control of network traffic, encryption mechanisms were some among them. Over time, the attacks on the Internet and related systems have grown more sophisticated, while the amount of skill and knowledge required to mount an attack has declined. Attacks become more automated and cause greater amount of damage. With the digital revolution and increased use of Internet for operations, the nature and size of attacks have also changed tremendously. Modern vehicles nowadays come packed with automated software, creating seamless connectivity for drivers in cruise control, engine timing, door lock, airbags, and advanced systems for driver assistance. These vehicles use Bluetooth and Wi-Fi technologies to communicate that also opens them to several vulnerabilities or threats from hackers. Gaining control of the vehicle or using microphones for eavesdropping is expected to rise in 2022 with more use of automated vehicles. With AI being introduced in all market segments, this technology with a combination of machine learning has brought tremendous changes in cybersecurity. It is also being used to develop smart malware and attacks to bypass the latest security protocols in controlling data. Cybersecurity trends provide a considerable increase for mobile banking malware or attacks in 2019, making our handheld devices a potential prospect for hackers. All our photos, financial transactions, emails, and messages poses more threats to individuals. Another important security trend that we can't seem to ignore is targeted ransomware. Especially in the developed nations, industries rely heavily on specific software to run their daily activities. These ransomware targets are more focused, such as the WannaCry attack on the National Health Service hospitals in England, Scotland, corrupted more than 70,000 medical devices. Though generally ransomware asks to threaten to publish the victim's data unless a ransom is paid, still it can affect the large organization or in case of nations too. Security services. Security service can be defined as a processing or communication service that is provided by a system to give a specific kind of protection to system resources. Security services implement security policies and are implemented by security mechanisms. These services are divided into 5 categories and 14 specific services. These categories are discussed in the next part. Authentication. This is the assurance that the communicating entity is the one that it claims to be. The specific services in this category are peer entity authentication and data origin authentication. Access control. Access control means the prevention of unauthorized use of a resource. This service controls who can access a resource. under what conditions access can occur, and what those accessing the resources are allowed to do. Data confidentiality. The protection of data from unauthorized disclosure is the meaning of confidentiality. This includes connection confidentiality, connectionless confidentiality, selective field confidentiality, and traffic flow confidentiality. Data integrity. It is the assurance that the data received are exactly the same as sent by an authorized entity without any modification, addition, or deletion. The services include connection integrity with recovery, connection integrity without recovery, selective field connection integrity, connectionless integrity, and selective field connectionless integrity. Non-repudiation. This service provides protection against denial by one of the entities involved in a communication of having participated in all or part of the communication. Non-repudiation of origin and destination are specific services provided. Security goals. Three primary goals of information security are preventing the loss of availability, the loss of integrity, and the loss of confidentiality for systems in data. Most security practices and controls can be traced back to preventing losses in one or more of these areas. Availability means that assets are accessible to authorized parties at proper time. Integrity means that only authorized parties are allowed to modify the assets in authorized manner only. Confidentiality ensures that computer-related assets are accessed only by authorized parties. It can also be termed as privacy. Security in computing addresses these three goals. One of the challenges in building a secure system is finding the right balance among the goals. These three characteristics can be independent, can overlap, and can even be mutually exclusive. Hence, ensuring availability, integrity, and confidentiality while providing a secure system is the core of the different techniques of information security, and we will explore these in the coming sessions. This module provides an overview of the information security by mentioning the concepts of security, different types of information security, etc. The recent trends in attacking the information systems, the different services provided by a security system are discussed in detail. A security system must restrict the access to an object or data by ensuring the availability, integrity, and confidentiality to authorized and proper access. Hence, these topics are discussed here. Hope this session was useful for you. See you next time. Until then, bye.